Okay, guys, we're going to be taking a look at question 11 from the chapter 10 practice test in calculus. So we've got this polynomial p1 equals 1 plus 7x, and we're using that to approximate x plus 1 to the 7th power. We've got an interval, and it says to use remainder estimation, which is a reminder that this is the same thing as a Lagrange error bound. I just noticed that Lagrange is misspelled there, but who knows how it's really spelled. We're going to estimate the absolute maximum area or error. So our problem here is that a lot of times we feel queasy about doing this because what does that absolute maximum error mean? We can set maximum, almost any place, but we want to find, usually whether or not that error is tolerable, whether it's in a certain interval. And mainly when we're talking about Lagrange error, we're saying that, we have this part right here, which I'll highlight for you, that is the most nebulous part of the whole problem. Because what is that second derivative actually less than? If it's less than, if we say the error is less than 5, then certainly we can use 10 as a maximum, or we can even use 20 or 100. So how close to the maximum do we really need to get? Well, that just kind of depends a bit on the problem. So let's see what we've done here already. We've got the first derivative, we've got the second derivative, and then what I've done is I've actually taken a look at the graph of that second derivative. Now, this isn't something that you're going to necessarily be able to do on a test because it's not going to be a calculator test, but it's worth investigating what this looks like for us because, we're trying to learn here. So here's what my second derivative, my second derivative looks like. It's an increasing function. It looks as though our maximum is going to occur over here at x equals 0.1, and which makes sense since we have a increasing function. Also, you'll notice that at 0.1, the value of that second derivative is 67.641. Hopefully I remember that correctly when I did my work. It's kind of hard sometimes when you're switching windows like this. And 67.641, I think that's correct. I want you to know that, getting that number is probably the most difficult part of this. Everything else is formulaic. If you didn't if you're estimating here, 70 would be perfectly acceptable. I mean, if 67 is the actual maximum, you should certainly use 70 here. That would be a maximum. So it's just a matter of you kind of being comfortable with what we're doing. So that's our maximum. That's the actual maximum. Anything above that would work as well. If you're not presented with a graph, then you're going to have to actually do a little bit more thinking about this. This is a 5th degree polynomial. This second derivative is a 5th degree polynomial. It looks like our critical value here, the only place we'll have a critical value is where x equals -1, which is nowhere near this interval. So since there is no critical value in our interval, our function is either going to be always increasing or always decreasing. And, if it's always increasing or decreasing, then you just need to check the values at -0.1 and +0.1. And that will, definitely tell you where the maximum is. Another thing you can take a look at is, this function is definitely going to be increasing. If you take one more derivative here, that's not going to change positive or negative or anything like that. Substituting any number in our interval will make 1 plus x positive. Certainly 5 times 42 is positive. So basically the derivative here is always going to be positive in our interval from -0.1 to +0.1, which would lead me to believe that the maximum is going to occur at the right side of this interval, 0.1. That's where our maximum is, and that is where we found it, if you remember looking back at that graph. So I went and I crunched the numbers. Here's that formula again, the Lagrange error estimation formula. This time we got the maximum is the maximum of the second derivative multiplied by point of estimation minus c squared over 2 factorial. It might be hard to see what the point of estimation is. It could have been negative 0.1, it could have been positive 0.1. As it turns out, it didn't matter because we're squaring. The center of the polynomial is 0, as indicated over here and over here. So we just substitute our numbers and kind of crunch it down. We got 0.338 as a maximum. I'm sorry, I think that was a typo in the answers here, so we'll have to make a note of that. But it looks as though our maximum error is going to be 0.338. Well, if that's the maximum error, then certainly we could also say the error is less than 0.4. The error is also less than 0.5. So the exercise here is just to figure out, what are actual values of this error. So that's our question 11. Again, sorry that there's a typo in that answer column. Hopefully in the future years there won't be a typo there either. So that's our question 11, and we'll see you next time.